Hello, viewers. Welcome to the very first episode of our Axis Unboxed podcast, where we will talk about tough industrial challenges and smart automation solutions. So, our today's topic is for gas measurement and analysis system through our in-house manufactured sample handling system. To simplify this tough challenge, we have with us our esteemed guest, Mr. Sanjeev Chakrabarti, Head of Marketing and Business Development at Axis Solutions Limited. Good afternoon, sir. Welcome to the show. Thank you so much for your presence. Without taking much of your time, we will deep dive into the most awaited and important topic. So, sir, we will start with very first question, that is why SHS matter, and what are the industries like refinery, steel, cement, and why this product is much important in that industrial segment.
First of all, thank you, Harshit, for calling me and considering it suitable to reply to your podcast. And let me start about analyzer sample handling system. Now, I always say that analyzer is the superstar singer for any gas analyzer system. But might, if it is not good, then the show is bad. And the same thing is true in gas analyzer system. Mic is your sample handling system, and if it doesn't get the representative sample, a very stable sample, then the analyzer system is, will not give you a very reliable measurement. So that is basically like, the analogy why sample handling system is a different technology in itself.
So then when we talk about SHS, how SHS is made, so when we talk about Axis gives a complete solution or a sampling system with analyzers which are dealt in the major oil and gas industries or specific major refineries. So how SHS of Axis make is different from others?
As I said, typically, what we say that analyzer is as good or as bad as the sample it gets. So it is very important to get a true representative sample to the analyzer so that a reliable measurement can happen. So precisely why we say that a sample handling system is just not Q-works or plumbing, but it's the most essential part of it and needs to be designed specifically as per the applications for which it is intended to measure.
So we can say that SHS is just some random pipes and filters, sir?
That is true if you are actually going to design, a nice, artwork with pipes, so then I think, it's a plumbing, but otherwise I said it's a very important tool.
So when we talk about SHS as an important tool, and you said you defined it as a hero of the system. So what does it comprises of, sir?
Typically, we always say that an analyzer will be able to, give you a good reading only if your sample is, clean, not dirty, and the flow is stable. And in order to actually have a very clean sample, you need to have components to make it clean. To make it actually wet, you need to remove the moisture, and to make it stable, you need to control the temperature, pressure, and flow, because gas depends on the nRT equation, as we all know. And so the sample handling system is very critically important for any gas analyzer system.
So it sounds like a science fiction movie in terms of an industrial environment segment. So when we talk about this science fiction movie, and you told that SHS is a hero, so what are the first line of defense when we talk about the components and parts when the SHS is designed, sir?
The first thing in order for the sample to be correct is to do the aspiration of the gas, which requires the different types of probes. and that becomes the first element, followed by many other components. And if we talk about the probes, there are various different probes that is required.
So, sir, can you please enlighten us with the types of probes you told about?
Depending on the process and the industry, there are different types of probes. For example, heated probes are required in the refineries, where you need to keep the sample above the dew point so that there is no moisture that comes in. Then we are talking about high dust retractable probes, which are very important to remove the dust and the moisture. And since the cement plant will have lot of dust and very high temperature, you need to do the heat exchanging and keep the probe safe. And so in cement plants, I think high dust probes are more important. Then there are other probes. For example, we are talking about with special probes like the Denister probes. Typically, the Denister probes are used to remove the droplets, typically like the mist droplets as we call it, which are very common in flue gas desulfurization, or we talk of the sulfur recovery unit applications in the refineries and the power plant. And the last one would be, I think, the dilution probe with a controller which is used. Many applications are there where the analyzer cannot take the raw gases because of the concentration of the gases that are there, which can damage the analyzers, and so dilution probe with controllers are used. So that way there are many different probes which access designs and manufacturers depending on the application that it is designed for.
So basically, sir, the probes are like umbrellas for different designs and different applications. And how Axis designs it, sir? Is it just about the basic or standard solution that you give, or it varies from case to case basis, sir?
As you rightly talked about the umbrella, you have to have the right umbrella, for a situation. For example, if the umbrella is not selected correct, you might get drenched, and the analyzer subsequently, will get wrapped. So it's important to select the right umbrella, and by saying so, I always say the sample handling system, there is nothing called standard. It has to be designed and manufactured as per the application of the industry for which it is supposed to be used and optimized.
So now the sample part is done, sir. We have collected the sample. So how it should be kept in the moving state, sir? How it moves?
So once you have aspirated or extracted the sample from the stack or from the process stack, it needs to be pumped. The gas will have to move to the analyzer, and to move the gas you need to have various pumps, sample gas pumps, and there are again various types of sample gas pumps. For example, the diaphragm pumps are very good in case of dry gas sample to be given to the analyzer. But then there are bellow pumps which are very unique and important if you have to have smooth flow into the thing. And of course, if there are liquids, because moisture is a very common factor that you get in the stack and process. So if there are liquids involved, then the peristatic pump are also involved to remove the liquids that comes along with the samples. So there are the three main pumps, as we call it, within the sample handling system.
So on a lighter note, sir, are these pumps similar to the fish tank air pumps, sir?
You can say it if you are actually monitoring the emission of the goldfish, but otherwise these are very special pumps.
So, sir, as I rightly understood, you have been into multiple SHS fixes, and so I would like to understand from your side, sir, what was the complex SHS fix that you have been executed, and how was your experience?
Uh, exactly, I think I would cite you one example, where a car fuel filter was used in one of the cement plants that I know of. And of course, it worked for a week, and then it totally miserable. And then once it failed, I think the maintenance team had a run, for the money, handling and addressing that particular issue.
So it is always rightly said that you have to customize the SHS according to the system and the solution that you will be providing.
Yes.
So without much ado, we will jump on a topic which we call it as the sample handling systems, tubing, and the regulator part that connects the system. So what are your takeaways on tubings and regulators, sir? And how does that really matter? Or I would rightly say that is it just one part of a plumbing thing, or how it is differentiated?
Tubings are, of course, a very important element. Tubings and fittings, both I say, is very important element of the design of the sample handling system. The right tubing should be there because otherwise it might actually absorb the sample gas. It could actually remove a lot of the components which are critical to reach to the analyzer for the sampling. We should not be losing it. And I will say, for example, if we are designing tubing for the SEMS system, I think it is always preferred to have PTFE tubing rather than SS tubing. And when we talk about the regulators, those are the most critical elements, and Axis has a range of regulators to address different requirements of the industries. And the regulators that we design typically are of PTFE lining, and these are, if at all it is used of SS, it is a passivated SS that is used. All the internals that are there are actually of PTFE, and it's important that if the regulator is not correct, I think it will flood the analyzer, and the analyzer will go bad much before the warranty period. It can't last. So Axis manufactures and designs a complete line of regulators for the different purposes and the applications.
So sir, it is not just about connecting the dots, it is about connecting the dots rightly so that you can get the specific amount of operational efficiency or the desired output that is mattered. Now, we have talked a lot about analyzers, system, in-house manufacturing. So, we also have to talk about the business value. So, beyond keeping analyzers happy, what's the real payoff for the plants?
The gas analyzer systems are critically important for many things. It is required actually for the process optimization. It is required actually to keep the environment safe. It is also required actually to have a safe function of the process. But all said and done, I think as in terms of the business value, I think all businesses comes in threes. And the three main elements that the analyzer systems gives is the compliance, where few alarms or faults should come, and it should actually be friendly to the audit so that the regulations are in place. Second, we are talking about the reliability. The analyzer output or the measurement that is there should be accurate, and it should serve the purpose in order for the optimization of the process to happen, which is again very critical. And the third thing that we talk about is savings, because to have the right savings, I think the process optimization and the accurate results, the right type of analyzers and the sampling systems as a complete thing has to be designed right. So it's always a solution. It's not the component that one or two different component and the standard set of components has to be designed. You have to take the inputs properly and justify to have the business values of all the three parameters that we talked about.
Okay, sir, one last question. What is your golden rule for designing SHS?
I will say the best way or the best approach to do the designing of the sample handling system is to start with the analyzers and do a reverse engineering from the analyzer till the probe. First of all, you have to understand that the sample handling system objective is actually to give a representative sample to the analyzer and save the analyzer for its duration of life. So understand what the analyzer needs to remain safe and engineer it backwards. Design actually like the pumps, the filters, removal of the moistures, the probes, so that the analyzer remains safe. And that's, I think, the advice that I will give, that design it actually like from the reverse engineering side.
So, as I would rightly understand, Axis is not just a component supplier. We can call it as the cardiologist, which keeps the heart pumping smoothly and safely. So, am I right, sir?
Absolutely. I mean, you hit the dot you talked about. And the only thing is, I will say that check on the prices. The sample handling system and the complete system that Axis charges is much lower than what an expert cardiologist will charge you. So that is what I will say, that okay, it's not expensive although it's complex, but then we are somebody in the country with Make in India and global expertise, can understand the process for last 25 years, so we can design the right system for you.
Thank you so much for your time. Thank you, viewers, for turning into Axis Podcast. I would like to know your thoughts and comments. I would also request you to keep sharing this podcast, subscribe to our YouTube channel, and also I would like to know that what are the other topics that you would love to listen to us. And thank you for joining to Axis Unbound. Thank you.